Good, right. All hail the sentient cloud. Begin testing.
Hello everyone. First off, I'd like to apologize for taking so long to get a video out. I was working on the text buffer for the final implementation of the text editor, and I ran into some trouble getting that to work. I still haven't actually gotten it to work as of yet. So instead of spending more time kind of just trying to figure that one out, I figured I would put that on the back burner and instead focus on some computer graphics instead. And in pursuit of that, I decided I was also going to build a game from scratch. No game engine, and mostly just basic system libraries. Now, for this particular project, similarly to other stuff I've been working on, I'm using C++, and I'm going to be using OpenGL, and in this case, it's going to be the X server, or X11 API. And I'm going to be making the Snake game for this first foray into computer graphics. So I went ahead and I created a new project, and I created a makefile and a couple other things, but that's all pretty much the same as most of my other projects, so I'm not going to bother showing that. What I am going to show you is something that I put into the defines.hpp file, and that is talking about system-dependent code, or platform-dependent code. So in this case, I've got some if-defs here that define the current platform that I'm running on and allow me to determine which platform and then compile code based on that platform. So in this case, I'm running on Linux, and so this FO platform Linux macro is going to be defined. And so I'll show you guys when we get to that bit of code what that code looks like. I also went ahead and defined some types for integers because I prefer the sort of Rust or Zig integer types as opposed to the char and short and int stuff that you see in C and C++. So I've got these defined, and then some asserts to detect if they are the correct size. If they're not the correct size, then I don't want this to compile. And then down here I've got a really basic result enum. There will be more members of this enum in the future, but for now these are really the only ones that I'm going to be dealing with in the near future. So let's move to the platform header. So right here I've got some other stuff, type defs and structures. Most of this stuff is fairly self-explanatory. Basically, all that this platform header is going to do is contain all the kind of platform-specific code that I plan to include. So let's go to the Linux implementation. Okay, so as you can see up here, I first check if the platform Linux macro is defined. And then from there, I include, in this case, I'm including the logger and then a bunch of other libraries. So the first one that's really important here is the X11 headers. So in this case, the way that you create a window on X11 platforms is by using something called Xlib. There are other ways of doing it, but those are more complicated and I didn't really want to use them. And then EGL here I'll get to later. That's important for OpenGL, but I'll explain that in a minute. So I've got some static global variables here, and that's just for storing all the information about the window because I don't need there to be multiple windows created. I really just need the one. So I'm not going to bother storing this stuff in its own structure and then having the game hold on to that structure because it doesn't really need to. It doesn't need to know about it. So the first thing when you're using X11 is you connect to the X server, and that's done through this XOpenDisplay function. And assuming that everything goes well, we move on to getting the screen. Now the screen kind of represents information about the monitor, and so for example its resolution and its refresh rate, things like that. Then this XKB set detectable auto repeat. So if you know how X11 implements auto repeat, the way that it works is you hold down the key and it will repeatedly send a press event and a release event over and over again. which means that you can't tell if a person is just pressing and releasing the key repeatedly or if they're holding the key down. And so detectable auto repeat comes in and just prevents the X server from sending the release events whenever the person is holding the key down. So we'll just say press, 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 and then when the person actually releases the key, it'll send the release event. So that's what this is doing here. Then I'm figuring out where on the screen the window should start. So in this case, I'm just assuming that I want the window in the middle of the screen. And then from there, I get the root window, which is basically the whole screen is kind of the root window under the X11 scheme. And then creating a window on that. So that's how you create the window. And now it's not on the screen yet. It's not visible, but it is created, and so I can do things relating to that window. So for example, I can do things like set borderless on it, remove the borders, or I can set it to full screen right here. So I can also set the input masks. So if I want to get button press events, then I need to make sure that it's got this button press mask as a part of its input mask. And so you've got a bunch of these here. I'm not going to be using all of them for this first project, but in the future I will almost certainly need to implement stuff for these various input masks. And so once all of this kind of setup is done, I map the window, which is where it actually puts it onto the screen, and then tell X11 to wait until all the commands are pushed through and then return. So it tells me how big the window is that I created. In destroy window, all I have to do is close the display. Everything else is handled by X11. So it makes things fairly easy. And I'll ignore this context thing here for a second and move down to pull events. So this goes through and checks if there are any events in the event queue, and if there are, then it will just go through and consume those events. So right now, I'm only looking at these key press and release events, and then the client message event, which checks if the window got deleted. And then there may be more in the future again, but for the moment, these are all that I need. And that is essentially all of the kind of X11 code. Now, going back to this create OpenGL context function, in order to use OpenGL, you need the context. The context stores information about the renderer at kind of like a lower level. So it will store information about buffers that you've allocated or shaders that you have linked and are using. So in order to use OpenGL, you need an OpenGL context. And the way that you create that usually is done with very system-specific libraries. So for example, on Linux, you would use something called glx. If you're on Windows, you would use something called WGL. However, lately, the Khronos group, the people who make OpenGL, who defined the standard, have come out with this thing called EGL, which is capable of working on multiple platforms. And so that is what I'm going to be using to create an OpenGL context. So if I decide in the future that I want to implement Wayland, if you guys know what that is, that's, I'm not going to explain what it is. But anyway, if I want to do that, I can still use EGL for that. And in fact, EGL is the only thing that's supported for that. And so I figured that since I didn't find any decent kind of videos on EGL, and that EGL is kind of a useful thing to have information on, I figured I'd include it and make a video with it. So to start with, I've got a structure that contains all the pertinent EGL components, so the display, the context, the surface, things like that. And I go through and first get the EGL display, and I'm specifying the X11 platform, because if I don't, then I will instead get the Wayland platform, which I don't want because I'm on Wayland right now. And then call initialize, and that just starts everything up. Bind API. So typically, EGL is meant for use with OpenGL ES, which is OpenGL for embedded systems. And so normally it would use the OpenGL ES version, but I don't want to do that. I want it to use the regular OpenGL version. And so I need to tell it to bind that API instead. Then configuration attributes. So in order to use OpenGL, I need to find a working frame buffer that works with the things that I want. So for example, I want it to support 8-bit color sizes here, and I want it to support things like the OpenGL renderable type. And so in order to make sure that all that happens, I have to specify all of these different options. And then it goes in and it checks if that frame buffer configuration is available. And it will return a frame buffer that is at least fits that. There are a bunch of other default ones that I didn't include here. You can look that up using the EGL documentation, but I didn't think it was necessary to include all of them. I just wanted the ones that I think are pertinent. After I've gotten the configuration, I check for I set up the context attributes, and in this case I need version 3.3 of OpenGL. That's a very standard version, a lot of GPUs support it, so I figured it would be good to have. And then I also make sure that I'm getting the core profile. There's a compatibility profile that is often supported, but core profile is expected to be supported by default, and I don't need the older OpenGL stuff, like versions like 2.1 I think is one of the versions that's commonly supported. I don't need that, and I don't really want to deal with it. So I'm just sticking with core. And if I'm debugging, or I guess if I am not debugging, technically speaking, then I want to make sure that I've got the debug context. So from there, I just call create context with all of those attributes, and then I've got a working EGL context, and setting up the surface with the window. This is the X11 window that I created. And then from there, I call make context current, which tells OpenGL to target this particular context with all of its function calls. And so from there, after this goes through and works, I can make OpenGL calls that will actually run. And I can show you that if I go to this file, game.cpp. I went ahead and included OpenGL, and I've got a bunch of stuff here, so it'll destroy the window and deinitialize the logger, and it'll also create a window, obviously. But down here in the run loop, I went ahead and have a setup for the OpenGL context. So it will attempt to create the context. If it fails, then I'll obviously have to break out. But assuming that works right, then I can call an OpenGL function. So in this case, I'm setting clear color to this really ugly color here, and then telling it to clear the screen, and it'll automatically set the color to this. It's kind of like a really dark yellow that looks kind of gross, but it's very clearly not the kind of black screen that you would see if it failed. And then from there, I tell EGL to swap the buffers, and at the end here, I'll tell it to terminate. And so, if we run this, and I show the screen, you'll see I've got a working OpenGL context with the clear color obviously working. So now I have a working OpenGL context, a working window. I can get inputs and all sorts of stuff like that. And so now I'm ready to start working on the renderer. That's what's going to be the next episode. So I hope you found this interesting and or useful, and I'll see you in the next episode. Bye.